Alright, so you tossed the ball straight up into the air and caught it at the moment that you released it. Now, if we let the vertical position be defined by y, then up is positive and down is negative. Let where you release the ball to be where y equals 0. So initially, it was going really fast in the positive y direction. So I should have a very steep slope in my position time graph. Then, at the very top where it stopped moving to get ready to come back down, the slope of the position time graph should be 0. Okay, so it stopped, turned around, fell back down to your hand. And so it was going down when it reached your hand. So the velocity was negative. So the slope of the position time graph should be negative. And if I connect these 3 points of interest, I'll get a function that looks similar to a parabola. So it was going very fast and stopped, and then turned around and fell back down. So then it had a very negative velocity, and note that it's a parabola, so the slope of the initial portion is equal and opposite to the slope, the final position. Now, if delta x equals vt plus 1/2 at squared, that's the equation for a parabola. This parabola, though, is inverted. It's upside down. So, we'll have to take into account that in a minute. Now, initially, the velocity was very positive, so let's mark that as a very positive velocity on my graph. And then at t, I'll let that be the time where it reaches the highest point. Mark it over here on your velocity graph. Okay. And then at the end, or when you caught it, I guess it would really be at 2t. It was very negative. So we mark that spot down in the far right there. And then we can connect those points. Okay, so the slope of a velocity time graph is still acceleration. And that acceleration, that line, is negative. Which means it was pointing down the whole time. So negative acceleration there. And the value of that slope is constant. And every single time you do this experiment, you would get the same exact slope on the planet Earth, close to the surface. So, if we want to write our equations for this, we need to start with what the acceleration is. And the reason why that object stops and comes back is because of gravity. This is a phenomenon, and there's an acceleration due to gravity. There can be a force due to gravity, and there can be an acceleration due to gravity. But gravity is not the answer to what is the acceleration. It's due to gravity. Very common mistake. Alright, so now let's go back up here and look at our graphs. And it is a negative parabola, or it's upside down. And that rate at which it's changing, the acceleration, is about negative 9.81 meters per second squared. Now, for the sake of our course, we're going to use negative 10. It makes all the math a lot easier to add, subtract, multiply, and divide by 10. That way, when you're doing a multiple choice question and you are not allowed to use your calculator, then you can do the math pretty quickly. So all of WebAssign has been coded for 10, so please use 10. If you use 9.81, WebAssign will probably count your answers wrong. So please use 10. The only reason why we're going to use it is because it is absolutely acceptable to use on the AP exam. Alright, so let's come up with the equations for this vertical motion. Instead of delta x, let's write it as delta y. And instead of just v naught, let's call it v naught y, so we know that it's in the y direction. This will be really important when we get into two-dimensional motion. Times time. Now remember, this is a negative graph. It's upside down parabola, so we need a negative 1/2, and the symbol we use for the acceleration due to gravity is a little g. And we're going to substitute the number 10, the value of 10 meters per second squared, in for g. So you're just going to take the absolute value of that constant. And then times t squared. So that is the position equation, just written in terms of the vertical position. Alright, so the velocity equation, it should be v equals v naught plus at. But for our graph, it's a negative slope. So it's v equals v naught minus gt. You can put some y subscripts in there to remind you need to use the y velocities. Again, this will be really helpful when we are in two-dimensional motion and you have to keep the x's and y's separate. And then the third equation that we got from combining the first two equations, v squared equals v naught squared. And it's going to be minus 2g delta y because of that negative sign up there in the delta y equation. And again, it's in the y direction, so you can put in the subscripts for the y velocities. And those are not three new equations. They are the same equations. We use 10 meters per second squared for g, so you need to make sure that all of your values are in SI units, meters, seconds, kilograms. And it's not three new equations.